You think you know the story. You've seen the movies, read the books, and it always ends the same way. A fiery rock from space, a blast of unimaginable power, and the sudden, dramatic end of the dinosaurs. The asteroid, a single massive blow that wiped the slate clean and paved the way for our own existence. It's a clean, simple, almost mythic tale of cosmic disaster. But what if that simple story is a myth itself? The truth is, the asteroid was only half the picture. It was the climax of a disaster movie that had been playing for millions of years, and the real killer, the one that truly sealed their fate, was something far more insidious, far more silent, and far more deeply woven into the very fabric of their world. We're about to explore the hidden evidence, the secrets buried in rock and time, that completely changes how you see one of the greatest mysteries in Earth's history. To understand this, you have to first picture that final day. A celestial rock, roughly 10 kilometers wide, hurtles through space at over 20 times the speed of sound. You imagine it, a silent, stony giant, hurtling toward a world it would soon change forever. As it tears through the atmosphere, the sky ignites, turning day into an inferno. You see a flash so bright it would blind you from 1,000 miles away. Then, an impact, an explosion of kinetic energy equal to billions of atomic bombs. A moment so violent it instantly vaporizes the asteroid, a chunk of Earth's crust, and everything for hundreds of miles around. It left behind the Chicxulub crater, a scar in the Yucatan Peninsula, half the size of Yellowstone National Park. It's a truly cataclysmic event. A shockwave rips across the globe, triggering earthquakes and volcanic eruptions. Gigantic tsunamis smash into coastlines. But the worst part wasn't the initial blast. It was what happened next. The sky is choked with dust and soot, the sun blotted out for years. Global temperatures plummet. Plants can't photosynthesize. The food chain, which for 150 million years had been a finely tuned machine, grinds to a halt. Herbivores starve, and with them, the carnivores. The dominant creatures of the planet, the dinosaurs, meet their end not in a flash of fire, but in a slow, suffocating cold. It's the ultimate cosmic winter. You have to admit, it's a pretty good story. And for decades, scientists thought that was the end of it. The smoking gun. But even with a story this dramatic, some parts just don't fit. Dinosaurs had survived mass extinctions before, so what made this one different? For a while, it was a mystery, a puzzle with a missing piece. It wasn't until a young geologist named Walter Alvarez found a thin layer of iridium, a rare element from space, in the rock record that the asteroid theory gained traction in the 1980s. The discovery of the Chicxulub crater itself, confirmed in the 1990s, seemed to close the case. We had our murderer, the proverbial killer asteroid. But what if the murder weapon wasn't what truly killed them? The dinosaurs were like a patient already suffering from a devastating illness when the asteroid came along. The asteroid didn't kill a healthy kingdom. It finished off a sick patient. Think of it like this. If you have a perfectly healthy tree, it can probably withstand a strong gust of wind. But if the tree is already rotten inside, that same gust of wind will knock it right over. That's the real secret of the dinosaur extinction, that they were already rotting on the inside. In fact, a handful of scientists in the 1970s and 80s even wondered if there were other causes, but their ideas were, for the most part, simply dismissed. They didn't see the full picture yet. So, a big question for you. Could the dinosaurs have survived if their world hadn't already been in such a state of decline? And for a lighter moment, here's a joke for you. Why did the T-Rex cross the road? To get away from the asteroid, but he still couldn't outrun extinction. But the story isn't over. A hidden truth still lives on today, not about a single rock, but about a dying planet. This mystery will completely change how you see the world. We're about to peel back the layers of time and discover the sickness that had been consuming the planet for millions of years. What's your favorite dinosaur? Tell us in the comments below, and let's get curious together. And with that, we'll dive deeper into the world that was already crumbling, long before the final blow. The asteroid was the final nail in the coffin. But who built the coffin? Who was poisoning the air, warming the oceans, and weakening the dinosaurs long before that cosmic rock arrived? You have to travel back in time, not just to the moment of impact, but to a world that was already in crisis for millions of years. This hidden killer wasn't a flash of light in the sky. It was a slow-motion, geological catastrophe unfolding on the other side of the planet. Imagine you're standing in what is now India. But instead of the familiar landscapes we know today, you're looking at a desolate, fiery expanse. For over 1 million years, fissures in the Earth's crust, not a single volcano, but a vast network of cracks, poured out an endless river of lava. These are the Deccan Traps, and they are unlike anything you can see today. They covered an area larger than Texas, a volcanic province so immense that if you were to stack the lava flows, they would be over 1 mile thick. This wasn't a sudden explosion. It was a persistent geological pulse that changed the very chemistry of the atmosphere. The air around you would be thick, hazy, and acrid. Millions of tons of sulfur dioxide, carbon dioxide, and other toxic gases billowed out into the atmosphere. The effects were a 1-2 punch that sent the global climate into a chaotic tailspin. The carbon dioxide, a greenhouse gas, began to slowly warm the planet. Oceans started to heat up, sea levels rose, and the world got a fever. But then, the sulfur aerosols would kick in, acting like a cosmic sunblock, reflecting sunlight and causing temporary, yet dramatic, global cooling. This was a planet with a fever and chills, constantly lurching from one extreme to another. The dinosaurs, which had evolved to thrive in a stable, warm world, were now living in a state of chronic environmental stress. It was a silent sickness, a slow poison that was already disrupting their finely tuned ecosystems. You can get a tiny glimpse of this today if you visit Yellowstone National Park. The geysers and bubbling mud pots are a vivid, miniature display of the Earth's inner turmoil. But imagine that scale magnified 1 million times over. Not a national park, but an entire continent. That's the kind of power that was on display. The atmosphere was a volatile soup, causing acid rain to fall over the continents and the oceans, corroding habitats and disrupting delicate marine life. It was a world on the brink. And here's a quirky fact for you. The Deccan Traps eruptions didn't all happen at once. Scientists have found evidence of multiple, massive, eruptive phases, with one of the most significant pulses occurring right around the time of the asteroid impact. The two events, separated by thousands of miles, may have been cosmically and tragically intertwined. It makes you think. How do you prepare for a crisis that unfolds over millions of years? You can't. A species can't evolve fast enough to cope with constant, radical shifts in temperature and habitat. The dinosaurs were weakened, their food sources were becoming unreliable, and their resilience was gone. The asteroid, when it finally arrived, wasn't a surprise attack on a fortified kingdom. It was a final blow delivered to a kingdom already brought to its knees. Here's a little joke for you. Why did the T-Rex get a terrible cough? Because the Deccan Traps gave him a bad case of prehistoric bronchitis. With the planet so chaotic, what do you think was the biggest challenge for the dinosaurs? Was it the heat, the acid rain, or something else entirely? What's your wildest theory? Let us know in the comments below and join the discussion. The story of the Deccan Traps is just the beginning of the other theories. We've seen how Earth was sick. Next, we'll dive into how that sickness caused an even greater disaster. You've imagined the Earth as a sick patient, but let's go deeper. What if that sickness wasn't just a contributing factor? What if the sickness itself was the one and only cause of death? This is the first of our 5 other theories. A theory so radical, it directly challenges the reign of the asteroid. It posits that the Deccan Traps, that vast, fiery volcanic province, was more than just a coincidence. It was a planetary-scale doomsday machine that could have been the sole killer of the dinosaurs. For millions of years, this volcanic furnace didn't just simmer, it roared. It spewed out so much lava that it covered an area larger than the state of Texas. Imagine that scale. A world transformed into a desolate, scorched landscape. But the lava was only half the problem. The real culprit was the invisible poison that filled the air. These were truly the Earth's own dragons, breathing out gases that choked the sky. The first breath was a heavy dose of carbon dioxide, a greenhouse gas that began to slowly cook the planet. Ocean temperatures rose, and polar ice began to melt, disrupting the stable, warm world the dinosaurs had known for ages. But then came the second breath, a massive pulse of sulfur dioxide. Sulfur dioxide is a killer. When it mixes with water vapor in the atmosphere, it forms aerosols, tiny droplets that reflect sunlight back into space. It's like the Earth put on a suffocating gray blanket. This caused a rapid, short-term drop in global temperatures, a volcanic winter that plunged the world into darkness and cold. So, you have a planet caught in a devastating climate paradox, slowly heating from one poison, then suddenly freezing from another. This constant, radical swing between hot and cold destabilized everything. It's an environmental horror show that makes the asteroid's impact seem like a quick, clean hit. The consequences were far-reaching, and for the dinosaurs, fatal. The sulfur aerosols didn't just block the sun. They also created a relentless storm of acid rain. This wasn't just a drizzle. It was a global deluge of diluted acid that poisoned lakes, rivers, and the land itself. It's a world where the very rain is a slow-acting poison, and the scorched earth is a testament to the planet's own destructive power. A quirky fact for you: the sheer volume of magma from the Deccan Traps is estimated to be so vast that if you could somehow pour it into Lake Michigan, it would fill the entire lake nearly 10 times over. And the destruction didn't stop there. The oceans, the lungs of the planet, were suffocating. The constant climate shifts led to ocean acidification and rising temperatures, which killed off marine plankton, the microscopic organisms at the base of the food chain. No plankton, no small fish, no small fish, no big fish. And suddenly, a massive portion of the Earth's life was gone, taking with it a crucial food source for many creatures, including the dinosaurs. It was an extinction event that began from the bottom up, long before any asteroid showed up on the scene. It's a compelling, frightening thought that our own planet was the true source of the Great Extinction. Here's a little joke. Why did the dinosaurs get a bad case of indigestion from the volcano? Because it gave them heartburn for millions of years. So, if the Deccan Traps were already wreaking this much havoc, poisoning the air, acidifying the oceans, and destabilizing the climate, It raises a profound and provocative question. Did the asteroid impact simply finish off a world that was already doomed? Did the asteroid even matter? Tell us your thoughts below and share your wildest theories. But the story gets even weirder, because what if the killer wasn't even from our own planet at all? Next, we're going to turn our gaze away from Earth and look to the stars for our next suspect. We've looked at the Earth's fiery wrath, a disaster that brewed from within the planet itself. But what if the killer wasn't even from our own world? What if the dinosaurs met their end, not because of a rock, and not because of volcanoes, but because of a cosmic event so vast, so powerful, it could reach across the vastness of space to extinguish life on our planet? This is our next theory. A thought-provoking idea that the extinction of the dinosaurs was a direct result of a blast from a dying star millions of light years away. You have to imagine a star at the end of its life. A colossal sun far larger than our own. It burns bright and fast, and then, in its final moments, it explodes in an event known as a supernova. It's the most powerful explosion in the universe, an eruption of energy so immense that for a brief time, the star outshines its entire galaxy. But what if one of these spectacular events happened too close for comfort? What if that blinding flash of light was accompanied by a silent, invisible wave of death? A powerful blast of gamma rays and X-rays hurtling through the cosmos at the speed of light, directly toward Earth? This isn't sci-fi from a movie like Star Wars. This is real, theoretical science. Such a blast wouldn't have been a dramatic impact like an asteroid. It would have been a silent, unseen killer. A wave of high-energy radiation washing over our planet. But our atmosphere is a fortress, right? It protects us. Well, for the most part. This kind of blast is so powerful that it would have torn through our atmospheric defenses. The radiation wouldn't have reached the ground directly. Instead, as it struck the upper atmosphere, it would have created a cascade of chemical reactions, primarily turning nitrogen into a kind of reddish smog of nitrogen oxides. This would have given the sky a sickly, reddish-brown color, a hauntingly beautiful sign of the apocalypse. But the real danger was what that cosmic smog did to our planet's vital sunscreen, the ozone layer. This fragile shield, which protects all life on Earth from the sun's lethal ultraviolet UV radiation, would have been shredded. The ozone layer would have been depleted for years or even decades. The result? A silent, invisible catastrophe. You think of dinosaurs as tough, scaly beasts. But without the ozone layer, they would have been vulnerable. You would have seen plants wilting under the intense, unblocked sunlight. Phytoplankton, the microscopic life that forms the base of the marine food chain, would have been decimated. And the dinosaurs themselves, exposed to this constant UV bombardment, would have been subject to severe mutations, cancers, and widespread sterilization. It's a terrifyingly elegant theory, a kind of cosmic sunburn that ended a kingdom. And here's a quirky fact. A single gamma ray burst can release more energy in a few seconds than our sun will in its entire 10 billion year lifetime. It's a stark contrast to the dramatic violence of the asteroid. There's no fire, no shockwave, no dust cloud. Just a quiet, persistent bombardment from a dying star, leading to a long, slow death for life on Earth. And here's a joke for you. What's a dinosaur's favorite constellation? The Big Dipper. It was easy to find when the ozone layer disappeared. It's a terrifyingly beautiful idea that our fate could be tied to an event so far away we can't even imagine it. With so many powerful and dangerous things in the universe, you can't help but feel a sense of awe, even at the danger. So here's a question for you. What's a cosmic event you'd love to witness? A supernova? A meteor shower? Tell us in the comments. The possibilities are endless. We've gone from a rock to a volcano to a dying star. But next, we're going to bring it back to Earth and dive deep beneath the waves to explore our next theory, the Great Ocean Collapse. We've looked to the heavens and to Earth's fiery heart for a killer. But what if we need to dive deep beneath the waves? The oceans, which cover over 70% of our planet, are often called the lungs of the world. They regulate our climate, produce most of our oxygen, and are home to an unimaginable diversity of life. But during the age of the dinosaurs, these lungs may have started to fail. The oceans themselves became a silent, suffocating graveyard. And this is our next theory. The Great Ocean Collapse. This theory is a direct consequence of the Deccan Traps volcanic doomsday. As those volcanoes spewed millions of tons of greenhouse gases into the atmosphere, the world began to warm. You know what happens to a cold can of soda when it gets warm, right? It goes flat. Well, the same thing happens to the ocean. As the oceans warmed, they lost their ability to hold dissolved oxygen. The deep waters, already naturally low in oxygen, became completely anoxic or devoid of oxygen. It was like the ocean was slowly holding its breath, and it couldn't breathe out. And here's where the zigzag narrative really comes in. You might imagine the surface of the water, still bright and full of life. But beneath the waves, a silent horror was spreading. This lack of oxygen created vast dead zones, areas where no complex life could survive. Imagine a pristine beach in Florida, a place full of vibrant sea life, suddenly becoming a biological desert. That's what happened on a global scale. This isn't just a theory. We have evidence of this happening in the geological record. Rock layers from that time, particularly in deep marine sediments, show a distinct absence of the normal marine fossils and are often rich in organic matter that didn't decay because there was no oxygen to break it down. It's like a fossil graveyard, a silent testament to a world that was suffocating. This anoxia didn't just kill the deep-sea creatures, it collapsed the entire food chain from the bottom up. At the base of the food chain were the microscopic plankton, the very foundation of marine life. They were wiped out in massive numbers. No plankton, no small fish, no small fish, no big fish, no big fish, no giant marine reptiles, like the mosasaurs. It's a domino effect, a kind of biological cascade that rippled across the entire planet. The land-based dinosaurs were already struggling with unstable climates and acid rain. But the collapse of the oceans meant the entire global ecosystem was in free fall. A quirky fact for you. Scientists can still find evidence of these anoxic events in today's oceans, though on a much smaller scale, in places like the Gulf of Mexico, where pollution and warmer waters create modern-day dead zones. It's a scary thought, that something so vast and fundamental to our planet as the ocean could become so sick it brings about a global extinction. The dinosaur extinction wasn't just a single event. It was a series of intertwined catastrophes. You can't help but wonder how fragile our world really is. Here's a little joke. What's a dinosaur's favorite kind of fish? A suffocated one. Just kidding. It's a bad joke. But the science isn't a joke. The ocean is a world we're only just beginning to understand. It's full of strange and wonderful secrets. So, here's a question for you. Share a mind-bending ocean fact with us. We want to hear them all. The ocean sickness was a major factor. But there's still more to the story. We've talked about global calamities. But what about a microscopic killer? Next, we're going to shrink our focus from the entire planet to a single organism, and our next theory, a prehistoric pandemic. We've explored grand, global catastrophes, a cosmic rock, a fiery volcano, a dying star, and a suffocating ocean. But what if the killer wasn't something grand at all? What if the dinosaurs were brought down not by a massive, visible event, but by something microscopic, insidious, and utterly unseen? This is our next theory. A prehistoric plague, a silent sickness that swept through the dinosaur kingdom, leaving them weak and defenseless long before the asteroid ever appeared. You have to imagine a world already under stress. The climate is in chaos, food is becoming scarce, and the air is thick with pollutants. You've seen this in our own history. When a population is weakened by famine or war, a disease can spread like wildfire. What if something similar happened to the dinosaurs? This theory suggests that a novel pathogen, be it a virus, bacterium, or parasite, emerged and began to spread rapidly through the dinosaur population. Maybe a new species of mammal, which had co-evolved with a specific pathogen, introduced it to the dinosaur kingdom, where there was no natural immunity. It would be a bit like the European diseases that devastated Native American populations, but on a geological scale. The most terrifying part of this theory is how plausible it is in the context of the other disasters we've discussed. The chaotic environment of the Deccan Traps would have created the perfect breeding ground for disease. Ecosystems were being destroyed, forcing different species into closer contact. The warmer, wetter conditions in some areas could have led to a boom in disease-carrying insects. You can just imagine it, a silent sickness that started with a cough, a fever, a slow decline in health. Without modern medicine, without any understanding of what was happening, the dinosaurs would have been completely helpless. And here's a quirky fact. Viruses and bacteria are some of the most successful life forms on Earth. And they've been co-evolving with complex life for billions of years. They were just waiting for their moment. You can picture it. A herd of once mighty triceratops, their numbers dwindling, not from a predator, but from a silent killer. The once dominant T-Rex, struggling to hunt, his body ravaged by a fever. It's a tragedy that's so familiar to us. We've faced our own public health crises, and we know how quickly a virus can change everything. The difference is, the dinosaurs didn't have scientists, hospitals, or vaccines. They were utterly on their own, a kingdom being systematically dismantled from the inside out. And here's a joke for you. Why did the T-Rex refuse to see the doctor? He was afraid of getting a T-Rex-scription. This theory provides a crucial missing link, a way to connect the slow, environmental disasters to the sudden collapse of a dominant species. A weakened, sick population is a population that is highly vulnerable. The asteroid, in this scenario, wasn't a killer of a healthy kingdom. It was a coup de grace delivered to an already dying one. It simply finished off what a silent, microscopic killer had already started. In a world with a deadly disease, you can't help but ask a very modern question. Would a T-Rex get a vaccine? And more importantly, would it even have worked? Let us know what you think in the comments. We've now explored 5 alternate theories, from the cosmic to the microscopic. But the most compelling story of all is how they all fit together. Next, we're going to pull all the pieces together and present the ultimate, most scientifically supported hidden truth, the 1-2 punch. We've explored so many possibilities. A cosmic rock, a fiery volcano, a dying star, a microscopic plague. You've heard the evidence for each. But what if they all point to the same devastating truth? What if it wasn't a single event, but a perfect storm of disasters, a 1-2 punch that no life on Earth could survive? This is the ultimate theory. The most compelling and scientifically supported story of the dinosaur extinction. It's the story of how a kingdom already on the ropes was finally knocked out by a single, perfectly timed blow. Think of it like a heavyweight boxing match. The Earth was in the ring, and the first punch was already being thrown. This was the slow, insidious attack of the Deccan Traps. For hundreds of thousands of years, the volcanoes had been hitting the planet with a relentless series of jabs and body blows. You've seen how they destabilized the climate, caused acid rain, and led to a suffocating ocean. The dinosaurs were getting weaker, their food sources were becoming unreliable, and their habitats were changing. They weren't thriving. They were just surviving. A sick patient trying to recover from a chronic illness. This was the first punch, the one that sapped their strength and left them vulnerable. And then came the second punch. The Chicxulub asteroid. This was the knockout blow, a catastrophic haymaker that would have been devastating on a healthy planet, but was absolutely fatal on a weakened one. The impact didn't just cause a global winter, it amplified the one that was already happening. The dust and debris from the impact, combined with the already polluted atmosphere from the volcanoes, created an even more dramatic and prolonged period of darkness. It was a world caught in a crossfire of cataclysms. The asteroid strike may have even triggered a final, massive pulse of volcanic activity at the Deccan Traps, linking the two events in a terrifyingly direct way. This theory makes sense of all the missing pieces we've explored. It explains why some species survived and others didn't. It's why the extinction wasn't a clean, immediate sweep. It was a long, drawn-out process, a meteosis that saw a slow decline, followed by a rapid, final collapse. The fossil record supports this, showing that dinosaur diversity was already in decline long before the asteroid hit. They were already fighting a losing battle against a changing world. Here's a quirky fact. Some scientists believe that the asteroid impact might have been so powerful it changed the spin of the Earth slightly, which could have further affected ocean currents and climate. It's a terrifying thought. A single rock changing the very rhythm of our planet. This is the big reveal, the truth behind the hidden evidence. It wasn't one killer. It was two, working in concert, one slow and silent, the other sudden and violent. The asteroid gets all the credit, but the volcanoes were the real masterminds of the extinction. Here's a joke for you. Why did the asteroid get all the credit for the dinosaur extinction? Because the volcano was a master of a cover-up. So, with all the evidence in front of you, what do you think killed the dinosaurs? Was it the asteroid, the volcanoes, or the 1-2 punch that sealed their fate? Let us know in the comments below. We've come to the end of our theories, but not the end of the story. The dinosaurs are gone, but their legacy lives on. Next, we're going to talk about the survivors. The dinosaurs that didn't disappear at all. The story of the Great Extinction is a story of loss, of a world changed forever by a catastrophic 1-2 punch. But it's also a story of incredible survival. Because the dinosaurs, they didn't truly disappear. You see them every single day. A crow on a telephone wire, a hawk circling in the sky, a pigeon strutting down the street in New York City. They are all living dinosaurs, the direct descendants of the giant beasts that once ruled the planet. For a long time, we thought of birds and dinosaurs as completely separate. But the scientific evidence is overwhelming. Birds are dinosaurs. Specifically, they are avian dinosaurs, a surviving lineage of the theropod family that included giants like the T-Rex and the velociraptor. The proof is in the fossils: hollow bones, three-toed feet, and even the existence of a wishbone in both birds and their dinosaur ancestors. It's a mind-bending truth, one that makes a majestic bald eagle soaring over Yellowstone National Park a living, breathing testament to the survival of a prehistoric lineage. A tiny hummingbird hovering at a feeder is a distant, vibrant relative of the most terrifying carnivores to ever walk the earth. So how did they survive? The 1-2 punch of the volcanoes and the asteroid acted as a biological filter. It was a chaotic, global reset button. The largest, most specialized dinosaurs, the long-necked herbivores, the massive armored tanks, the giant carnivores, couldn't survive the sudden and prolonged global winter. Their size was a disadvantage. They needed massive amounts of food that simply wasn't there. But the smaller, more adaptable, and critically feathered dinosaurs were perfectly equipped for survival. Feathers provided insulation from the cold, and their small size meant they could survive on a fraction of the resources. They could eat seeds and insects, food sources that were more resilient to the environmental collapse. It was a story of evolution selecting for the small and the adaptable over the large and the powerful. You're looking at a living fossil every time you look up. This idea isn't new, either. The discovery of Archaeopteryx in Germany in 1861, a fossil that was a perfect mix of bird and dinosaur, was one of the first pieces of evidence to show this incredible connection. And a quirky fact for you: the closest living relative to the Tyrannosaurus rex is actually the chicken. That's right, the next time you see a chicken, you're looking at a direct descendant of the most fearsome predator in history. The extinction didn't end the dinosaurs. It simply took away their monopoly on the planet and allowed one small, resilient branch of the family to flourish and diversify into the thousands of bird species we see today. Here's a little joke for you. Why did the chicken cross the road? To prove to everyone that it was a dinosaur. This survival story is one of the most powerful and hopeful parts of the extinction narrative. It reminds us that even from the greatest catastrophes, life finds a way. It's a legacy that is still all around us. So now that you know the truth, what's your favorite bird? A powerful falcon? A playful parrot? Tell us in the comments. The story of the dinosaurs is not over. It's a story we're still writing every day. We've explored the end. But what does the future hold for our understanding of the past? Next, we'll dive into the final mysteries that scientists are still working to solve. The dinosaurs are still with us, a vibrant, feathered legacy flying over our heads every day. But the story isn't over. Science gives us answers, but it always leaves us with new questions. And when it comes to the Great Extinction, the biggest mysteries are still being debated and researched today. We've come a long way from the simple asteroid story. But the truth is, the search for a complete picture is far from over. One of the biggest lingering questions revolves around the exact timing of the 1-2 punch. We know the Deccan Traps were erupting, and we know the asteroid hit. But was the final massive pulse of volcanic activity a direct result of the asteroid impact? Or was it just a truly horrific coincidence, a perfect storm of geological and cosmic forces colliding? Scientists are using high-resolution geological dating and advanced rock analysis to try and solve this cosmic whodunit. It's a true scientific mystery, a race against time to precisely time events that happened 66 million years ago. A quirky fact: a thin layer of iridium-rich clay, known as the KPG boundary, is found all over the world in the geological record. And it acts as a universal bookmark for this catastrophic event. Every time we find it, it's like we found a page from the ultimate cosmic crime scene. And what about the survivors? We know the birds made it, and so did many mammals, amphibians, and crocodiles. But the question is, why did some groups make it, and others didn't? It wasn't just about size. Why did some specific species of birds survive when their cousins were wiped out? The answer probably lies in a combination of factors: their diet, their ability to burrow, and their unique physiology. For example, many animals that burrowed underground were protected from the initial firestorms and the long, cold darkness. It's a testament to the incredible and unpredictable nature of evolution and survival. It's a research effort that takes scientists to fossil beds in Montana, labs at NASA, and drilling sites in the Yucatan Peninsula. A true all-hands-on-deck effort to piece together the past. The greatest mystery of all, however, is what happened in the first few thousand years after the impact. This period, known as the Paleocene-Eocene transition, is a fossil-poor no-man's land. The world was a mess, and the fossil record from this time is still so sparse that we're only just beginning to understand how life rebounded. How did new ecosystems form? How did mammals, once small and living in the shadows, begin to diversify and take over the ecological niches left behind by the dinosaurs? The story of the extinction is epic. But the story of the rebirth of life is just as fascinating. And we're only in the prologue. Here's a little joke for you. Why did the paleontologist get fired from the museum? Because he couldn't remember what the dinosaurs did for a living. The search for answers is ongoing. A constant reminder that science is a journey, not a destination. New discoveries are made every year, and with every new piece of evidence, the story becomes a little clearer, a little more detailed, and a little more awe-inspiring. So, if you're as fascinated by these cosmic mysteries as we are, and you want to see more content like this, comment yes below and join the community of cosmic curious minds. But our journey for this video has one final stop. Next, we're going to wrap up our epic tale of loss and survival with a final, monumental thought. We've traveled back in time 66 million years. You've journeyed to a world on the brink, witnessed a catastrophic 1-2 punch from Earth's own volcanoes and a cosmic rock. We've seen a kingdom of giants fall, and we've discovered that their legacy is still flying over our heads every day. The story of the dinosaur extinction is a story of loss and survival, a dramatic chapter in the epic saga of life on Earth. But the search for knowledge never truly ends. The pursuit of these answers isn't just about satisfying a morbid curiosity about the past. It's about understanding the very nature of our planet and our place in the universe. The extinction was a planetary-scale experiment, a real-life dataset that tells us how a complex ecosystem responds to extreme, multifaceted stress. It teaches us about climate change, about the fragility of life, and about the incredible resilience of evolution. The more we learn about that past, the more we learn about our own future. We're still drilling at the Chicxulub crater, still analyzing rock samples from the Deccan Traps, and still discovering new fossils that challenge our understanding of what happened on that fateful day. Every new piece of data is a new clue, a new paragraph in a story we're still writing. You stand here now, a human being, a species that only exists because that cosmic tragedy unfolded exactly the way it did. The earliest mammals that survived the cataclysm were tiny, burrowing creatures that lived in the shadows of the dinosaurs. They were our ancestors, a powerful and humbling reminder that our existence is a direct consequence of this great extinction event. It's a story that ties all of us together, a collective past written in the very rocks beneath our feet and the stars above our heads. Here's a little joke for you to end on. Why did the paleontologist break up with his girlfriend? Because she was a total fossil and he wanted something new. The universe is full of mysteries waiting to be solved. From the hidden evidence of the dinosaur extinction to the monsters lurking in deep space, there is no end to the awe and wonder that science can uncover. So if you've enjoyed this journey, if you've felt the awe of cosmic discovery, then join our community of cosmic curious minds. Like this video, subscribe to the channel, and hit the notification bell so you don't miss our next adventure.